Hey, welcome back to our lab 11, and that's video 2, and hopefully the last one. So I promised a more compact week, and I hope I'm delivering it for you. So problem 3, we also worked on that during the lecture videos. The problem, as a society, we cannot change the past, but we can act to transform our future. Studies spanning more than 30 years, covering virtually every state that uses capital punishment, have found that race is a significant factor in death penalty cases. This trend is sometimes not transparent when absolute numbers are used to report on this issue. So here are the distributions as we've discussed in class. This is a contingency table, right? Where we have the number of, out of all of the cases that went to jury during a certain period of time. Here are the number of non-whites that received death penalty, and that's the number of non-whites that did not receive the death penalty. And that's the number of whites that, when convicted, received death penalty, and that's the number of whites that did not receive the death penalty once convicted. So when we look at the absolute number, an equal number of white and non-white convicted felons received the death penalty. Faced with this data, can we conclude that there is no bias against non-white individuals, or would it be a misconstruction of the data, right? So it's important that we be careful with absolute numbers, as we've been talking about all throughout today, right? Be wary when people are giving you raw data, raw counts, because those raw counts typically need to be put in context in order to figure things out, right? Now, the question is, do these data provide evidence for a relationship between the decision for the death penalty and the race of convicted individuals? The hypothesis: no, nothing is going on. Race and death sentence are independent. The race of death sentence does not vary. The rate of death sentence decisions does not vary by race. And the alternative is that something odd is going on here. Race and death sentence decisions are dependent, and the rate of death sentence varies by the race of convicted felons. Inferential analysis. We can use the chi-square test for independence to determine if deviations from expected are sufficiently large for us to reject the null hypothesis, and hence demonstrate that using absolute values to dismiss racial bias is not a legitimate approach, because the distribution is not homogeneous in the population, right? We don't have a flat distribution. We don't have the same number of white individuals, black individuals, and Hispanic individuals, and Asian Americans. This is not a uniform distribution. Because these distributions are varied in the population, we cannot use raw numbers. We need to put numbers in context. And now you know from the lecture that we can get the expected counts, assuming independence, between race and the decision for the death penalty, using the multiplication law. If you don't know what the multiplication law is, go back to the lecture video. I explain it there. You will not have to compute that by hand, luckily. I just want you to know that these can be calculated, and this is what R is doing when we run the chi-square test for independence, okay? So as usual, step 1, just check if the conditions are okay. Each case only contributes to one cell in the table. Each particular scenario or cell has at least 5 expected cases. We'll go with the idea that we'll meet that condition, but we can always check that once we spit out the expected counts later on and come back to that. I'm saying conditions are met here because I've already computed that in class with you. But you can kind of leave this blank until you run things and look at the expected, and then you can come back and complete for the next exercise where you don't know the results. All right, I digress. So let's run the analysis. First, we're going to read in the data. So we have death sentence, the death sentence data set. So I'm loading it. And this is what it looks like. You have the death sentence. And for each individual, each convicted individual, we indicate whether they got the death sentence and their race. Individual number 2, did they get the death sentence? Yes. What color are they? What race are they? This. So on and so forth. At some point, we'll have the no convicted that were non-white and the no convicted that were white. Okay? So that's the data set. Come back. Now we're going to build the contingency table. This one. So you don't have to build this by hand ever. And you've learned how to do that already, right? So you just use the function table. And you say, oh, look inside the data set DS, the one we just loaded, and get the variable race, put that in one direction, and get the variable death sentence and put that in the other direction. We've done that in lab, I think, 4, when we were looking at the relationship between promotion decisions and gender. We're doing the same thing here. And we're storing this table in an object that we call DS underscore TB. And asking R to print it out. So here is the contingency table. 251 non-whites that were convicted did not get the death sentence, and 508 white individuals who were not convicted, who were convicted did not get the death penalty. And then we had 33 non-white individuals that were convicted and got the death sentence, and 33 white individuals that got convicted and got the death sentence. Now in class, I showed you how to compute the expected probabilities under the hypothesis of independence between getting the death sentence and race, right? Applying the multiplication law. And from those probabilities, we can compute the expected counts in each one of these cells. The expected number of non-white individuals who did not get the death sentence, the expected number of white individuals who did not get the death sentence under the hypothesis of independence. And same thing for these 2 other cells. We will not have to do this here. You do need to know how these things are obtained, but you don't need to compute these things by hand because the function chi-square.test will do that for us. Just as we did before, I'm going to save the output of the chi-square test into this object called ds_chi, and I'm going to run the chi-square test. And in this case, we need to do only 2 things. We need to put the name of the data set in there. Don't worry about the proportions in the population. It will compute the proportions, the probabilities for independence using multiplication law. And we just ask R to correct for the fact that we have not a continuous distribution really of the data, because the data is not continuous, and chi-square distribution is continuous. So applying this correction is nice. So you just leave that true all the time. So if we run this, we get that the probability of getting this particular distribution is 0.008. Okay, and this number is a little different from the one we saw in class because we're applying the correction. Okay. But the decision is the same because this number is less than 0.05, so we reject the null hypothesis that there is no relationship between the race of a convicted individual and whether or not they get the death sentence. So there is a bias. Now, we need to get the observed and the expected distributions to figure out whether or not that bias is against non-whites or whether the bias is against whites. It could go either way, right? So like just the p-value does not tell us that. It just tells us that race and the decisions are not independent. So let's look. The first table here. So note that in this case, you don't even need to put names or anything. All you need to say is, please spit out for us these contingency tables that are stored inside the output for the chi-square test. Make sure you use the correct name that you gave. $ observed, and then the same thing for the expected. So the first one is the observed, the second one is the expected. So we can see that less individuals who are not white don't get the death sentence than would be expected under the null hypothesis, that there is independence between race and the death sentence, right? So you would expect 261 of the convicts, of the people that were convicted and were not white, to not get the death sentence. But less people do not get the death sentence if they're not white. To the contrary, if you're not white, the expected would be that only 23 individuals would get the death sentence. But in fact, 33 got the death sentence, more than would be expected under the independence hypothesis. So there is some bias against non-whites when you have that, when you're making the decision for the death penalty. It's the opposite for whites, which is very sad. That, just by chance, you would expect about 498 individuals to not receive the death penalty, but more than that don't receive the death penalty if they're white. And you would expect about 43 to receive the death penalty if race had nothing to do with that decision, but less than that receive the death penalty. So white individuals are benefited by that system, are privileged by that system, and individuals that are not white are being biased against in this system, okay? So the interpretation is that there is evidence that death sentence decisions are related to race and biased against non-white individuals. You're going to work on example number 4, which is also an example that's looking at whether or not two variables are independent. In this case, the number of social behaviors exhibited by individuals with autism spectrum disorder when they received treatment and when they didn't receive treatment. So if there is a relationship between the two, he would suggest that treatment is doing something, but you need to look at the expected and observed counts to see if people that are under treatment are exhibiting more behaviors than expected if treatment were not related to those behaviors, okay? So you work on that, and on the key of the guided activity Lab 11, you can look at the responses, okay? I wish you the best week ahead, and hopefully I'm not giving you as much work as usual to do in order to relieve you a little bit from due to all the work you've done last week on the midterm. All right, bye-bye.